So here we're talking about two populations, population densities, which are the number of people living on 1 square mile of land. It changes for each state and it changes each year. So we're looking at both these two populations, and North Carolina and Hawaii, and we're studying what happens to their values. So first of all, we see that Hawaii starts at 188.6. So there's our vertical intercept for Hawaii, 188.6. So the initial year, 2000, Hawaii had a population of 188.6. Similarly, North Carolina had a population of 165.6 in the initial year. Okay, but one interesting thing to note is that 188.6, this guy goes up by 2.3 people on a square mile of land each year. So it goes up roughly like that maybe. Now North Carolina goes up by a faster rate, so 3.1 people on a square mile each year. So what does that mean for us? Well, since this one's rising more rapidly but starts off lower, and this one's rising less rapidly and starts off slower, and this guy's faster, eventually these two guys will intersect each other, which that's why basically they'll eventually have the same population densities. One starts lower but rises faster, one starts higher but rises slower. When will the two states have the same population density? So we can approach this in a couple of different ways. We can do it graphically, or we can do it mathematically. So if we look at it graphically, we come over here and we plot them both, our equations, so clear out anything that we have in there now. And we type in 2.3, now we're going to have to use x unfortunately, plus 188.6, and we look at 3.1 x plus 165.6. Now we got to set our appropriate window. We have to make sure it goes at least up to 188.6. So in our window setting, we'll set x, the number of years. This is kind of confusing, but the x-axis, the number of years axis, let's just go from 2000 to 2010. And on our population axis, we'll go from 0 to, let's say, 200. That way we include the 188.6. We've got a nice round number. So there's one of them. There's the other one. That's kind of how we drew it, but we probably need to go out more years and maybe up a little bit higher. So let's just say we went up to 250. So there's one of them. There's the second one, and we can see that they're getting closer, but we're going to need to go out more years. So let's go out 20 years. So there's one of them. There's the second one, and they're almost there, but we need to go out probably maybe out to 30 years just to make sure we get that intersection point in there. So there's one of them. There's the other one. It looks like they intersect right about there somewhere. So I'm going to go to second trace. I'm going to look for the intersection. I'm going to just hit enter twice to select both curves, and then we don't really need to guess because we only have two equations on here, but usually it's good to try to get close to the intersection point. Press enter, and there it tells us that in year 28.75, well, that's 28.75 years after 2000, so in the year almost 2029, we would expect both population densities to be about 255. So in 2029, we would expect 255 people on a square mile of land, just because both of them are rising. Now whether that'll actually happen and continue this way, we have no idea, but that's a projection we could make. So when will the two states have the same population density? In 2029, which we found was like roughly 28.75, but you know that's pretty close to 2029. And what will the population densities be? They'll be equal 255. Excuse me. So this should be my 28.75 based on the way I drew the graph.